Hello engineers, ladies and gentlemen, welcome to another exciting tutorial. My name is Dele from Devops and Cut. Today we shall be learning about Terraform with its infrastructure as code. But today I'll be showing you how to write custom Terraform modules. So rather than have your Terraform files in just .tf files and running your Terraform code and applying, I will show you how to modularize your Terraform code. Now, there are a lot of the advantages of writing Terraform as modules into modules is that first of all, it helps to standardize your code. Some companies have some particular ways and standards how they write their code, or maybe, for example, an EC2 instance, they might say you need to have a key name in it, but sometimes without the standards, some people might provision an EC2 with a key name, or some might do that without a key name. So how do you enforce this? Modules is the way. Have your modules comprise everything the company wants, and then allow everybody else who wants to use the module to send in the parameters and provision their infrastructure. Another advantage of using modules is it helps us to encapsulate logic. So you can have all your routines of the logic in the modules, and then the user does not have to know what's inside the module. So this makes it more secure, and also we can separate our logic from our data that's been fed into the module. Another thing is it avoids code duplication, which is a big problem. For example, in a company, maybe we provision EC2 instances very often, different departments or different engineers, and we have to write the code each time to do the same thing. That is very inefficient. So with models, just have the model that does this, and everybody just uses that model, and passes in the parameters to build the infrastructure. So it is very efficient. Helps to standardize, helps to hide, to encapsulate logic, and also helps to reduce code duplication. So we'll do this two ways today. The first way, we shall provision our infrastructure. Will be a simple one on one virtual machine EC2 in one VPC in one public subnet. And then after that, we shall now refactor our Terraform code and then provision this new one as modules. So this way you would see the beauty and the advantages of writing Terraform custom modules. So grab your coffee, tea, drink, and I will see you at the terminal. Today's tutorial will be about how to use and write custom Terraform modules. Okay, let's do it. Hold on. That's how to use and write custom Terraform modules. So today we shall provision some infrastructure in Terraform, which I do it the traditional way. And after that, we shall refactor our code into a modular structure. Okay, so that's what to do. Okay, so now people ask, why do we use Terraform models? What is the need to have these models? Okay, now there are different reasons. One thing is to standardize everything we do. For example, you might be in a company where there's a certain way of writing code, a certain way of naming, and certain naming conventions and things like that. By having models, you can enforce that because you would hide the logic, and all they have to do is just to enter parameters. So that way you can standardize the way you work. So as I said, second way, as I said, is going to be it helps to encapsulate logic. So that way, with models, no one needs to know what's in the model. All they need to know is the parameters, what to supply, what to fit into the models to get the desired output action. Okay. Now, another reason for using models is for code reuse. There is no point where you have to. If your company does the same thing over and over again, you write the same code all the time. Maybe you always provision instances. You do this VPCs all the time. There's no point having to rewrite this every single time. That's very inefficient. So it promotes code reuse. So you can have a model for maybe EC2 provision and just supply the parameters, maybe the size, the number you want, and that's all. And it is easy. Another reason for models is it makes updates easy. Now imagine if you write your code for maybe instances, you've got it in maybe like 100 places, and then there's a change you want to make. You have to go into every single file, and update this. But if you use models, you just do this in one place, and it will propagate everywhere else. So for models, it makes updates very easy. Now let me just explain this. I read somewhere else. It says, hold on a second. I'll just read this for you. Let me copy this and paste here. Hold on a second. Okay. It's something about models here. Okay. Now it says, okay, it's quite common for companies to have rules for how resources should be configured. For instance, a company might have a policy of deploying AWS S3 buckets without public access and with encryption enabled. As a DevOps engineer, you could declare this configuration over and over again, okay, or your code. But there's a risk of missing some of the requirements at some point. Or you could use a much better approach and create an S3 bucket model that has the company's required configuration, and then use this model for all your future deployments. Okay? Makes more sense. So by creating a model that encapsulates the company's specific requirements for S3 buckets, you can ensure that all your deployments adhere to the rules set by the company. It also makes it easier to update the company's requirements in the future, as you only need to make the changes to that model instead of having to update all the instances of the configuration throughout your code. So you see, models are very, very efficient and important in today's world. So what is our task for today? Okay, so hold on. Our task for today is as follows. We shall create and provision a basic EC2 resource in one public subnet in a VPC. When we create this, we shall check it and see it's been provisioned. Then maybe we shall destroy this, and then we shall refactor this code. We shall refactor the EC2 resource and VPC resource into modules. We shall update our code, and then we shall provision this infrastructure again, but this time using the new modular configuration. Okay, so that's all we need to know. So let's start with the order of the day. So we should start first of all by configuring our AWS provider. So we shall create provider.tf file. Okay, so hold on a second, please. Let me just move this up. Make sure we are in git bash. Hold on, please. Yes, okay. So let's create a provider.tf file using the command touch. So touch and provider.tf. We need to do this for AWS provider. So that is okay. And then let's go into the file. There it is. Okay. So it's going to be AWS. Okay. And then, of course, our Terraform block. let me just paste it there. We've already done this. Hold on. There it is. We're going to build in the US East one. You can change this to where you're building yours. And so I'm building Terraform version 5 and above. So that is it for the provider.tf. And after that, now we're going to begin to do, I'd say, let's create our EC2 instance first of all. Okay, the EC2 instance. Now, okay, let's create our networking first of all. Okay, the networking, that'll be our VPC and the subnets. Okay, so let's create this now. So we need to create a file. So we'll touch networking.tf. Okay, let's also create a file called variables.tf because we're going to need to create variables. This as well. So hold on, touch variables.tf. Okay, that's fine. So the first thing we shall create is our VPC. Do that quick. Okay, so let's go to networking. It's been the networking file. So first thing is the VPC. Now you can see with the CIDR, there's going to be a variable. So let's just go to variables now and fix that. Okay, so that's variable. It's called VPC CIDR. VPC CIDR. Okay, and the type is going to be a string. Okay, so we go back to networking. Yeah, that error is gone. You can see that. Okay, so let's go on. What next we'll do? Actually, let's create because we're just doing the basic one. Let's create a default value for our VPC CIDR. So let's go back to variable, and the default value. Let's go default because we want to do this the other way. So default value. Let's make it 10.0.0.0/16. Okay, let's save. So that is all for the VPC itself. Okay, now we're going to create a public subnet. Okay, so next let's do the public subnet there. Then we shall make the subnet's CIDR block also a variable. So that's it. So you can underline subnet CIDR. So let's go to back to variables to add it. Sorry, wrong folder. This should be in the networking. Sorry. So that's you can see now subnet CIDR for the public subnet. It's underlined, which means it can't find a value for the variable. So let's go to the variables.tf we created. Create a new variable. It was called public. What was it called? Let's see what it's called again. It was called subnet CIDR. Okay, so subnet CIDR, there it is. On the default, let's give it a value of let's say 10.0.1.0/24. If you don't know about CIDRs, you need to learn about this. How to it's a very important part of networking. Okay, so that's the CIDR block for the subnet. Now let's go back to networking. Yeah, that's looking good so far. Next, we want to be able to reach the internet, so we shall create an internet gateway. This wouldn't need any external variables. We can just interpolate the VPC. So let me go there. Sorry, 1 second. Yes, so that is internet gateway creation. VPC ID is just the VPC we have here. AWS VPC. You understand that? And then we shall create the route table, routes, and the route table association. We'll learn about this. Please go learn about it. Today is just about modules, so I wouldn't go into this today. Route table and the routes we need for our networking. So we have the VPC, one public subnets, internet gateway, and that's to do. Okay, that's fine. So our variables.tf is updated. It has the two variables. We have only two variables in the networking.tf that needed to be referenced. So there's no error showing. Okay, it's fine. Okay. So now we need to go now and create our EC2 instance. And this will be created inside our VPC. Okay. So now let's go and create our EC2 instance. So let me go. So let's go touch ec2.tf. Give it any name, but okay, I just call it ec2.tf. Actually, let me call it my ec2. My ec2.tf. That's the file for creation for ec2. Let's go into the file there. Okay. So we shall create a resource for an ec2 instance. So there it is. Now, hold on. What happened? Lost. I think it's fine now. Oh, yes. Now you can see I've created three variables: count, AMI, and instance. Now we know that for an instance you need AMI as Amazon Machine Image. So we need to do a variable. Now I use the count here. Count here. So with this count, we're able to create any number of instances using just one resource. Okay. So once the Terraform says count, it will create a number of resources based on this count. But what we have done also is we have used the count, index of the count, to name the instance. Because if we don't do this, there will be an error because it will try and create two instances of the same name. Okay, so variable for ec2 count, AMI, instance type, which I use a T2 micro, and then subnet ID, obviously. That's the subnet ID we created in the VPC, so that it will know it's meant to be in the VPC. So let's update our variables. Let's all do the counts. Do the count first. Let's say let's create two instances. So variable, okay. We call it ec2 count, I think. Yes, ec2 counts. It should show up there. ec2 counts. Oh, sorry, one line. Let me just again, sorry. Variable. Okay. Let's see, ec2. Yes, that's the variable we created there. Now the default. We're going to make it 2. So we have 2 instances in a public subnet. Okay, that's done. Let's check again the ec2. There's still 2 more errors. AMI. Okay. Now I got this AMI from Amazon. You can go there and get an AMI. AMI is just a machine image. It's the base image that'll be used for the instance. Okay, so I got this one. Look at there. So let's go and put in the AMI here. It's called AMI for the variable. So we go back there. Let's do a variable for the AMI. Variable there. AMI has come up. Yes. So the default is what I got from the console. So default is going to be this. Yes. AMI. Now I'm going to do one for the instance type. Which I use a T2 micro. So let's go that variable. Let's go. Let me just show you if you can see what I'm doing. That one is still instance type is still there. So let's go to variable. default. Hold on, instance type. Yes. And the default is going to be T2 micro. That's a small one, so it wouldn't cost us any money. T2 micro. And we check this now. Yes. So no more errors. So this should create 2 instances in our VPC. So everything is looking okay so far. Yes, okay. So that's updated. Okay. So now we've done this. Let us run our Terraform and see if it's going to work. It should be fine. So let's run Terraform init. We're not going to build this. I'm using the local backend. It's just for simplicity. In real life, we'd use a remote backend, like an S3 buckets, and lock it with DynamoDB. So right now it's initializing the backend. It's going to initialize the plugins and provide the plugins for AWS. Help us to connect to AWS through the API. It's doing this. I'm leaving this to run so it can be real time. You can see how long it takes. It won't take too long because this is a very simple project. Okay. So it's initializing for the plugins, what it needs to connect to AWS, everything else. Okay, so that's successful. So let's clear this. So now let's run a plan. So Terraform plan. Okay, so the plan is like a dry run. It will show us what resources are meant to be provisioned, created, but it wouldn't create anything. We'd have to apply this to create. Okay, so it told us, yeah. So what's it say here? Let me move this up. Okay, it says that sorry, no, this what's that? No, that's a mistake. Sorry, trying to scroll up. Okay, it says plan. It wants to add 8. So what's that going to be? Let's see from bottom. As usual, I guess the VPC. We'll explain that. Next, probably the subnet. Yes, and then probably the internet gateway, route table association. Yes, the routes. Yes, internet gateway. Yes. So this is now instance. You can see it is my instance 1. Next will be instance 0 because it's an index. Instance 0, 2 instances. Yes, so that's correct. Okay, now so let's now apply this. So Terraform apply. I would use the auto approve option. Don't use it unless you know what you're doing. This will let us apply without getting the prompts of yes or no. So apply. So everything goes fine. We should have our infrastructure built in AWS anytime soon. I'll leave this running so we can see. Yes, it's on the plan. Let's see how long it's going to take. So right now we are doing the provision of infrastructure in AWS. Okay, there it's creating. It's done the route table association. Done that. Yes, it's still creating the subnets, creating instance 0 and 1. Remember 2 instances. Use the count index to name the instances so that they wouldn't have a conflict during creation. Okay, that's still going on. I'm going to leave it to run its course. Apply complete. Resources 8 added, 0 changed, 0 destroyed. I want to see what's going on with Terraform. Hold on, let me just clear this. We can use the command Terraform state list. Let's see what we have created. Hold on, please. Yeah, I can see the 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 resources we have created in Terraform. Okay, so now let's go to the console just to make sure that's been created, and then we shall come back and do some refactoring. queue. Okay, now so let's head over to the AWS console and see what we have actually provisioned. So now we shall go to the AWS console. See? Okay. Now let's go to EC2. Remember we provisioned 2 EC2 instances, so we should have two virtual machines running. Remember? Let's go into that EC2. Expect to see 2 running, which we provisioned with Terraform. Hold on, while it loads. Yes, the 2 running. Let's see what they are. Yes, my EC2 0 and 1 as we expected. That's fine. The all checks passed. Everything's running fine. So everything we did. Let's check our VPC. We have 2 VPCs: the default VPC and the one we created. Let's go to VPC. Remember, ours was CIDR was 10.0.0.0/16. So 2 VPCs, yes. One is default, one is ours. VPC there. Let's drag this down and see. Okay, that's ours there. You see, that's our VPC there, which we just created. That's fine. We should have one internet gateway created. Yeah, that's ours there, and that's the default one. Yes, so everything is fine. So we have successfully provisioned these resources in AWS using Terraform. So next, we're going to do this. We shall refactor our code to use models that are reusable, and then we shall apply again. Okay, now we have done our first apply. We have created infrastructure using the first style of code, which is just having resources, and then running Terraform and creating resources without using models. Now we are going to adopt the model method to create our infrastructure, the same infrastructure. So this is our plan. Okay. So we shall create 2 folders. One folder will contain the resources for our EC2 instance, which I call them my_EC2. Another folder will create the resources, will contain resources for our VPC. We call that my_VPC folder. And then in the root folder, we shall create a main.tf folder. From there, we shall write our models that we call the resources in the other 2 folders. Okay, so let's begin with this. So let me clear. Okay, so the first thing we do is let's make our 2 directories. First of all, we want to do directory for EC2 and then one for VPC. So make directory my EC2, my VPC. So this should create 2 directories for us. You can see now on the left, my EC2, my VPC, they're currently empty. Okay, now we're going to move our code. Remember, earlier on we had all our code for the EC2. Here it was inside my EC2TF. Remember, that's the before. And then the code for the VPC was inside networking.tf. And then we used the variable.tf to mark all the variables. So now, let's begin with the EC2 first of all. So we're going to move everything from the root into this folder. So let's do that. So let's move. Okay. Let's move my_EC2 into my underscore EC2 folder. Okay, so that's going to move there. You can see it's gone. It's now in here. There it is. So let's do the same thing. Let's move our networking folder. Also, we shall move it into the other one as well. So let's move this. Okay, hold on. Let's move networking.tf into my VPC folder. Okay. Yes. Done. Just moved. Okay, so we shall leave the provider there because that's for everybody, for the whole that's for this root level. Yes. What else? Now we have the variables file. We're going to have a variables file for each model. So each folder will have its own variable file. So let's create a variable.tf file for both folders. So let me just collapse this. Okay. So let's go, first of all, let's go into my EC2. Okay, and let's create variables.tf variables. Now let's go back out and let's go back into now my VPC. And also create a variables.tf there. Variables.tf folder. Okay, let's go back into the root. Okay, so what else? We're also going to need an output file, output.tf, because we're going to output our VPC's public IP. So, no, public subnet ID. It's going to be output so that it can be used by the EC2 when it's placing its instance. So let's go back into the VPC one. Okay, so my VPC, let's go back in there and let's create output.tf file to be used later. Okay, that's fine. Okay, now that's our file structure taking place. Okay, so now we have done that. We've created the folders. So let us go. First of all, let's see. If we go into the networking.tf. First of all, if you go there, you can see that there are three problems. These three variables are there. And then if you also go into my VPC, there's also two variables there. So now we're going to, this time, there'll be no default variables. But we're going to leave them blank so that there'll be inputs from the model level, from the root level. So let's first of all deal with the EC2. Okay? So EC2, first of all, we're going to do EC2 count. Let's just get the variables from the earlier configuration and just modify. Okay, so the first one is hold on, let's see this. Let me copy this one's way down. Okay, let's copy. Okay, so now we're in the EC2 instance variables. Okay, so now we do not want any hard-coded values, so we just put a type. So the type here is going to be count, is going to be number. AMI, the type is going to be a string. The instance type, we want to also apply this later, so it's going to be a type as well, a string. So So that's us taking care of the errors in the instance folder. Now let's try and fix the ones in the VPC. Networking.tf, you can see the two, hold on, yeah, the VPC cider and the subnet cider. Let's go back to the variables on the main, the old variable. Let's get them and modify that too. It's these two, the ciders. Let's copy that. Go back to networking.tf. No, the variables. Okay, let's paste it here. Also here, we're going to remove the default values so that we can pass them in later. That's the idea of models. You don't hard code. So the type cider is going to be a string. Yes, and then the subnet cider as well. Type is going to be a string too. Okay, so now if you check the networking.tf, no errors. All the variables have been mapped. And then if you go to variables, fine. My EC2, no errors. Variables, fine. Okay, so we're getting there. So now we have created the variables for each one. Now, if you look at the EC2 instance right now, let's see. Okay, it has. We're going to provision this instance virtual machine in the subnet ID instead. It's going to be in this. It's going to be in the subnets that we have created. Okay. Now, if you go to the VPC here, networking, let's look at the subnets. Now, it's a public subnet and the ID is from VPC. But how do we get this value to the other folder? We have to create an output so that we can pass values from one resource to another. So that's why we have created the output.tf file. Okay. So what we want to do here is well done. We've got the output.tf file. So we need to find a way to send it to the other one. Okay. So we need the public subnet ID. So let's create an output in the VPC. Yes. Output. And we'll call it say public subnet ID. So we know what it is. Public subnet ID. Now the value is going to be the ID of the public subnet. That's going to be this public, let's say, this public subnet, AWS subnet .public.id. Understand that? So that's going to be AWS underscore subnet .public.id. So it's going to output this value, and then it can be used by other modules. Okay, so that's that. That's going fine. Okay, so let's save. Now it's time to go back to the roots. We now will create our model, which will call those values. So let's go. Let me clear the screen for better visibility. Okay, so our model will be, we'll call it main.tf. You create on the root level and to call resources in the other folders. Okay, so let's create the model. Touch main.tf. Okay, so that's the main.tf. And the models will be created in this. I meant to be created in this file. Okay, that's main.tf. There it is. Okay. Now, let's first of all let's do the model for the EC2. I will call it my EC2 model. Okay. Yes. I've already written this out. Let's post it now. Now you can see what's happening here. The source is from the my underscore EC2 folder, which we have here. So it's going to read the values from here and read the resources from there. That's fine. Now EC2 counts, the variable. We've let that in. Remember, it was a type. We did not put the default value, so we're going to pass that into the model. Instance type 2, pass into the model. Now, the instance subnet ID is going to be from the output. One model. That's going to be from the output of the VPC model. So let me just drop the VPC model here so you can understand it better. Now, this is the VPC model right under. Let me create that. Yes, this is going to call the source you see is my VPC folder. It's going there too. And it's going to use this CIDR, pass that in at runtime. We also pass the subnet CIDR at runtime. Okay. So we have to do our variables folder again. And there we'll pass everything in. Okay. So let's edit variables.tf. First of all, this is, let me see this. It's still showing one error in the main. Instance subnet ID is equal to model.myvpc model. ID, yes. Public underscore subnet.id. That's the output. Let's see that. Let's make sure it's correct. Public underscore subnet.id. That's correct. Okay. Maybe we have to close and open again for it to actually read the correct thing. Fine. And now let's deal with the variables. Okay. So we're at the variables. There. Yeah, I'm taking the defaults. So let's take that off. Let's type. CIDR is a string. This also is a string. This is a number. This mi is going to be a string. And then instance type, also a string. Okay, so let's save. We're still having this one main file error. I think it's because of the it's still not reading. It's still not reading the public subnet ID. Let's see what it says. Yeah, instance subnet ID is not expected here. Yeah, and to fix this, let's see if we have it in the EC2. Let's see EC2. My EC2. That's why. It's not here. Subnet ID. The variable. Let's see the variables. It's not there. That's the problem. So variable. Let's create a variable for that. Instance subnet ID. And default is a string. String. Yes, so now the error is gone on Windows.tf. All I had to do was to refresh and come out and go Visual Studio Code so that it could update. So that's been done. So everything looks fine. So we have written most of the code. So now there is something left. Okay. Now we have no default values. We're going to pass these values at runtime. To do this, we're going to pass this through a TFVARs. So we're going to create a new folder, a new file. Let's call it hold on. I'll be on touch Terraform.tfvars. Okay, we create there. And from this, we shall create the values to pass into our modules at runtime. So let's go to our variable first of all, variables. Let's get the values we need to supply. So all these values here we need to be passed in at runtime. So let me copy this. TFVARs. Let me paste this there and then modify. Okay. So first of all, we need to send in the VPC CIDR. So all we have to do is just do VPC CIDR is equal to, and we want it to be 10.0.0.0/16. That what we want for VPC CIDR. Yes. Our subnets CIDR. Okay. We'll just do the same thing with this. For this, we want it to be 10.0.1.0/24. Yes. EC2 count. Remember I said we want to, if we did 2 instances, we do the same thing here. So we're going to do 2. That's all. Instance type, we want to have a T2 micro. So it's equal to T2.micro. What's it complete? I don't know. And then what's left? So I have one left. What's left is going to be our AMI. We'll use the same AMI we used before when we had a default one the first time. So let me just get the AMI and paste it here. So AMI. So we're using the same values as before, except now everything has been modularized. There. So you can see no errors. VPC CIDR, subnet CIDR. So here, imagine now this is the beauty of a model. Somebody says anywhere department, we need this 6 EC2s in public subnet. Just give them the model, and all they have to change is only this TFVARs file. They just put in their CIDR for the VPC, CIDR for the subnet, how many they want. Let's say now we want, let's say 3, let's say 4 here. EMI, and now we want maybe T through large. That's all they have to do, and they'll get a different they get a different outputs, different they can build a variety of infrastructure just by editing just one little file. Okay, so let's go on and run this. Let's hope it works well. Hopefully there are no errors. So let's do a Terraform init. That's how that goes. If any errors, it will pick it up and tell us something is missing. So there's an error here. In variables.tf line 14, in my EC2, line 14. Oh yes, subnet ID, so subnet type, so string, yes, so that's correct. Let's save this. That's the error of the job of Devops. You troubleshoot as they come through. You must know how to troubleshoot when you get any errors. So because errors are bound to be made. Okay, so let's do that again. Terraform init. anything else will come up. We shall debug as we go. So it's initializing the backend, initializing models. Okay, that has been okay. So the models have been initialized. Okay, let's clear this for visibility. Now let us do a plan. Terraform plan. Like a dry run, it will tell us what is being created. We're creating the same infrastructure, except that we have put our resources into models. Let's see how that goes. Error. Oof. Something else. Okay. Okay, it says reference on the undeclared resource. On my EC2.tf, line 5. Let's go there. My EC2.tf, line 5. Let's see what's there first of all. Line 5. Subnet ID. A managed resource, AWS subnet public. Has not been declared. Yes, that's correct. Oh, yes. So we need to set a variable. Remember, it's a different model now. It can read the value from the other one. So what we have to do here, we need to go into the variables, make this a variable. So let's just call it variable dot. Oh, interesting. Yes, I love this. Variable dot subnet. Let's call it instance subnet ID. Variable dot instance subnet ID. Remember, we call this variable subnet ID as well. This, where is it? Subnet ID. Yeah. So we'll just link to that. Yeah. So that way, it's going to get its value from that. So that is beautiful. That is correct. So now it's a variable, and the variable is just a type. It doesn't say we'll feed it in from the main file. So that's okay. Okay, that's done. Let's try again. Terraform plan. Okay, let's do Terraform init in case we need to initialize because the model has been tampered with. So Terraform init. Let's initialize all again. Yeah, these things happen all the time. You know, that's a day in the life of a DevOps engineer. You're gonna have errors coming up. You have to troubleshoot. You have to fix problems. Now, I'm leaving this in so you can learn as well and see how things can be fixed. So let's go Terraform plan now. If the init was successful, Terraform plan. Hopefully there'll be no other errors, but they always come sometimes. You know. Let's see what's going to be created. Let's see what will be created here. It's thinking. Terraform's thinking. Okay. It's okay. The plan seems to be fine. It's gonna provision 10 things. Remember, it was 8 before, so it's probably just the eight things plus 2 modules. That's why it's 10 now. Okay, so let's just go through and see. I said yes. The subnet model, the route table. Yeah, that's all I think we need. Okay, that's fine. So now we have to run apply and see if it will create our infrastructure. So let me smooth this up. Let me clear this so we can see clearly. Clear. And Terraform apply auto approve. Remember now, we made a change now. We're trying to explain to you how, the beauty of models. So this time we've changed the values in Terraform TFVAS. Let me show you again. Now we want to use a different image instance type. It was a T2 micro before. Okay, let's make it nano, T2 nano. So, okay, T2 nano. We're changing the count as well from 2 before to 4 instances. So now we'll see 4 instances. So now all you have to do is change your the parameters in here. Change what is inside the TFS file, and you create this, different combinations of the models, the VPC and the instances. Brilliant. Okay, so let me save that now. And let's run approve. There we go. Okay, so if all goes well, we should have 4 instances in the in AWS, the cloud, 4 instances of size T2 nano, and as well as 1 VPC, a public subnet, an internet gateway, route table, route table association. Yes, everything should be as before, except that we're going to have 2 more instances, as well as different sizes of instances. Since we're going on so far, let's see how long this will take. I will leave it running so we can have real life insight into how these things get built and provisioned. So the code is still running. Let's watch as this unfolds. As I said before, you can see there's some things, sales and destruction going on. So it's changing. It's destroying the old one and rebuilding the new. Now apply complete. Resources 10 added, 0 changed, 8 destroyed. So it destroyed the former 8, created 10. Brilliant. So we shall go back into the console to see if what we want has been created. Okay? As I said, models, the way to go. They help to standardize, anything in the workplace, rules, They help with code reuse, help with they make updates easier. They're just the way to do any kind of code these days. Okay, so let's go to the AWS console and see what has happened. Be right back. Okay. Now let's open this. Let's refresh. Let's go to EC2. Now we should see 4 instances running. EC2 023. Yes. Let's see. It's loading. Yes, 4 running. And then also they should be of type T2 nano. We change that in the TFS file. Yeah, we have 4. Correct. Type T2 nano. Oh, if anybody wants to create infrastructure, you can simply use this model by just changing the values in the TFS file. So this is a TFS file here. So let's say they want to change now. Instead of 4, let's say they just need 2. And then the size now, they want it to move it to 2, let's say micro. Okay, so all I have to do, all they have to do is save this. Want to save, they can run it and it will create that straight away. They don't have to touch any other code anywhere else. That's the beauty of models. So now, let's go there. Just do Terraform, apply, or Terra approve. And that's all we need to do. You stand, and we'll get our 2 C2s of type T2 micro. So anybody who wants to use the model will only have to edit the Terraform TFS file, which is beautiful. That's the power of models. Thank you very much. Well, let's just go. We shall after this we shall go into the console for one last time, just to see that we now have two instances running of type T2 micro. So let's just wait while this applies. It's being built right now. Before we had 4 of type T2 nano. Now we've asked to have 2 of type T2 micro. So we shall see the effects. Just like that. One small edit and TFS, and we'll have a whole new infrastructure. Apply complete. Okay, let's quickly go into browser. Hold on a second, please. Let me we should go to EC2s, and by now we should have 2 running of type T2 micro. That is the power of models. Just one edit, and you can change your infrastructure. Bear with me while this loads. It's a bit slow. There you are. 2 instances running. You see 2 right there. Type T2 micro. So that's it. So easy with the power of models. So thank you for watching. Hope this was very, very informative. Thank you. So that's it. You have learned today how to write custom Terraform models. So now we have solved one problem, that is code duplication. So now you can write code and reuse it. Brilliant. But there's still another problem, which I would reserve for our next tutorial. So there'll be part 2 of this tutorial. There'll be a continuation. Because what if we want to, like in the workplace, we want to run this configuration in different environments. We have the production, staging, development, and testing. Now, how do we run this? The same code in these places, or do we have to have different files or view folders for each environment? Okay. Well, the answer is Terraform workspaces. So the next tutorial, I'll be teaching you how to use Terraform workspaces. That way, we can have the same configuration, but different state files for different environments, which is brilliant. Okay, so don't forget, subscribe, like, and share. Please do this because it will encourage me to do more of these videos. They take time. Trust me, they're not difficult to make. They're not easy to make. So please share, subscribe, like, and I'll see you on the next tutorial, which will be how to use Terraform workspaces. Thank you, and see you.